Welcome to Sequences and Series, part 4 on the Infinite Geometric series. This is the fourth of 4 YouTubes. For today's lesson, it is necessary to watch part 3. You'll see it among my YouTubes. Part 1 and 2, I encourage you to watch, but it is possible to watch today's lesson without seeing 1 and 2, but you have to watch 3. Today is directly from part 3. As a quick reminder, I have 2 YouTubes that are both free to subscribe. It's Variety and Fun Math and Martin Tutorials. And as always, if you're not happy with a subscription, the free subscription has a full refund policy. Now that's a great deal. Today's lesson is going to both those YouTubes. And let us begin today's lesson. What we have in front of us is 4 lists of numbers. And as you might realize, they are all geometric series based on what we learned in lesson 3. This one we always multiplying by a half, or arguably multiplying by a half, depending where in the world you live. This one we always multiplying by minus a half. 128 times minus a half is 64, times minus a half, 64 times minus a half is 32, 32 times minus a half is minus 16. Here we're multiplying by 1 over 10 or 0.1, and this one we're multiplying by a fifth between each term. So these are all geometric series, but interesting one where R, that ratio, is always a fraction. And of course, geometric series, that ratio is not always a fraction. We learned that before, but these particular ones are always a fraction. And what do we go from there? Well, let's pretend, I'm going to show you something interesting. Let's say we have a pile of sand that's exactly 16 meters high. And for fun, we keep on adding half the previous amount. That's 16, so we add on 8. It comes up to 24 meters. Then we add on 4 meters. Then we add on half the amount. Something interesting will happen. The height of this structure will never ever go above 32 meters. You can carry on adding as long as it's half the previous amount. It will never ever go above a certain height. It sounds strange because if we're adding on infinitely often, forever, even 1,000,000 times or forever, it will always reach a limit. That's because we're adding on a small amount each time. And that's something interesting about a geometric series where that ratio is a fraction. Of course, each time we add on, it will go higher. The total, like here, the first 2 terms is 150. The first 3 terms is 175. But it will keep going up in small and small amounts, but the total will never go above a certain amount. So from here, let's go back to the formula we learned before. This is the formula for adding up the sums of a geometric series. Okay, so if we go back to this one, the third term is 25, but the first 3 terms add up to 175. This is the formula for adding the terms. And as a reminder, A is the first term, R is that common ratio, and N is a number of terms you want to add up. So if I go back to here, A is 100, and in this case, R, that common ratio, is a half. Here, that R is minus a half. Now, this is the next point. If that R is a fraction, if minus 1 is less than R and less than 1, okay, and very important, I wrote less than signs and not less than equal to, because we are not including minus 1 or 1. If R is between minus 1 and 1, R to the infinity equals 0. What I mean is, let's take any fraction, let's say 4/5. I take 4/5 times 4/5 times 4/5. It will keep getting smaller and smaller. And if I do it infinitely, that total will zoom in to 0. Whereas if I took 5/4, keep multiplying it, it will just get bigger and bigger. Check with your calculator. All right, so the whole point is, if that R is bigger than minus 1 and less than 1, R multiplied infinite times, r to the infinity is a quick way of saying r times r times r times r times r infinite times will zoom into 0. Okay, so let's go back to the formula we talked about a minute ago. Let's now remember we're calculating the number of terms. Let's say if we want to add up the first 7 terms, we plug in a 7. If we want to add up infinite terms, all the terms added together infinitely, it's r to the infinity. Now we just said a minute ago, if minus 1 is less than r, which is less than 1, r to the infinity equals 0, like that 4/5 times 4/5 times 4/5 dot 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 dot. So this r to the infinity I can replace with a 0, provided that condition with r is true. So S infinity, when that r meets this criteria, instead of saying 1 minus r to the infinity, I say 1 minus 0. And a quick way of saying 1 minus 0 is simply 1. And a times 1 is simply a. So the sum of to the infinity is a over 1 minus r, provided minus 1 is less than r, which is less than 1. So this formula is true. Let's say that r equals a third. But this formula is not true if r equals 7. Okay? And what really stunned me is that it's a simple formula. My intuition told me this would be a really complex formula, but that's why it's incredible. It's a simple formula. And what I love to do is just give examples. I made up this geometric series, 100 minus 20 plus 4 minus 4/5 dot dot dot. What's the sum of infinity if you had to carry on writing it forever? It's a over 1 minus r. That a, the first term, is 100. I see the r is minus a fifth. Each term we multiply by minus 1 over 5 to get to the next. So it's 1 minus 1 over 5, which is like saying 1 plus 1 over 5. As an improper fraction, it's 6 over 5. And I mean, you can take your calculator and say, what's 100 divided by 1 in the fifth? And 100 divided by 6 over 5 is like saying 100 times 5 over 6. And that equals 500 over 6, 83 and a third, or 83.33 reoccurring. These are all correct answers. No one specified how they want the answers, so they're all correct. And of course, if you're doing a course, do it the way your teacher wants it. And here's another question I made up. 400 plus 100 plus 25 plus 25 over 4. I'm multiplying by 1 over 4 each term. It's clearly a geometric. It's timesing by the same amount. And 1 over 4 is less than 1. Sum of infinities, a over 1 minus r, which is 400 over 1 minus a quarter. That's 400 over 3 quarters, which is 400 times 4 over 3. Remember rules of fraction, when you divide by a fraction, it's like flipping and multiplying. And that's, again, there's a few ways to write it. It's 1600 over 3, 533 and a third, or 533.33 reoccurring forever. They're all correct answers, and that's 2 examples using it. I find it incredible that it's a simple formula. See how quickly I did the questions. And thank you all for watching. If you enjoyed this YouTube, please click subscribe. If you did not enjoy it, also click subscribe. Whatever the case is, I've got 2 YouTubes, Variety and Fun Math, Martin Tutorials. You are encouraged to subscribe. Thank you all and talk to you all soon.